To further solidify this process, let's go ahead and do another example of graphing a quadratic in vertex form. Our next example is as follows: y equals 2 times x plus 2 squared minus 4. So again, we always want to start with finding our vertex. In the case of a quadratic in vertex form, we know that our vertex is the point HK. Now again, reminding ourselves that vertex form is y equals a times x minus h squared plus k. Again, reminding ourselves that when we extract the h value from our quadratic we're working with, we need to think opposite in terms of sign. So in reality, our h value here is equal to -2. Again, because there's a negative in front of the h in the vertex form. So in order to get a positive number, as we do here in our example of x plus 2, h has to be a negative. And then our k value is just the value in that last location right here, the constant added to the end. In this case, it's -4. So you think opposite with the h, but you don't think opposite with the k. So the h is our x coordinate, so -2, and k is our y coordinate, -4. So -2, -4 is the location of our vertex. Plotting that, I get that right here. So here's the point, -2, -4. So now it's around that point that we construct our t-table. So we've got our xy t-table here. I'm going to move that over real quick. Got our xy t-table, and we're going to put our vertex right in the middle of that, -2, -4. And just like we did on the previous example, the goal is to pick 2 points at least smaller than and 2 points at least bigger than our vertex. So our x value being at -2, I'm going to pick -1 and 0, and I'm going to pick -3 and -4 on the other side. Okay, so separating my work right here from my table, I'm going to start with plugging in 0 to my x and solving for y. So plugging 0 in for my equation, that leaves me with 2 times 0 plus 2 squared minus 4. 2 times 0 plus 2 squared minus 4. So bringing up our calculator, that is going to be a 2 times 0 plus 2, close parenthesis, square that, minus 4. Hit enter, and I'm getting a positive 4. So this is equal to 4. So that means when I plug 0 in for x, I get a y value of 4. Now that I plugged 0 in, I'm going to go to my next x value that I selected and plug in -1. So that looks like 2 times -1 plus 2 squared minus 4, and that equals what? So bringing our calculator back, we end up with 2 times -1, oh, not -1, 2 times -1, let me clear that out, 2 times -1 plus 2 squared, and then minus 4. Produces a value of -2. So when we plug in -1, we get a y value of -2. Now again, because we chose the x values we did, we know we have symmetry. -1 and -3 are each 1 unit away from our vertex of -2. Therefore, I expect to get the same y values. So because I got -2 when I plugged in -1, I know I get -2 for my y value when I plug in -3. Likewise, because the x value of 0 and -4 are both 2 units away, just on opposite sides, we know by symmetry that we expect the same y value for both. So because we got 4 when we plugged in 0 for x, we know we get 4 when we plug -4 in for x as well. So we now have several points that we can plot on our coordinate plane. 0, 4, 0, 4, -1, -2. We already have our vertex of -2, -4. We have -3, -2. And -4, 4, which is up here. This parabola is much thinner than the previous one, but it still lines up very nicely in the shape of a parabola. So we're going to connect these dots to give us the parabola that we were looking for. And there's the graph of the quadratic function y equals 2 times x plus 2 squared minus 4. Let's label some things to communicate we know where specific things are. Labeling our vertex, -2, -4. That's done. We want to label 2 other points now. I'm going to pick the 2 points to the left. So that would be a -3, -2 here. That's that point. And then this point way up here would be a -4, 4. So I've got my vertex and 2 additional points labeled. I now want to draw my line of symmetry, which goes, it's a vertical line straight through my straight through my vertex. And we want to label this. It's a vertical line, so we know that the graph of a vertical line is x equals wherever it goes through the x-axis. In this case, -2. So x equals -2 is the equation of my vertical line, the axis of symmetry.